Hello, welcome to another one of my videos. Today I'm gonna be doing a quick demonstration that's like for me a perfect example of a redox reaction. We have for this demo we're gonna need a strong oxidizer potassium permanganate, sucrose aka sugar. Here I have it like finely ground using a mortar and pestle and a blender lately. And sodium hydroxide as a strong base. You can use potassium hydroxide also, but sodium hydroxide is a lot easier to get and cheaper. And here obviously distilled water. Water obviously it can be used like out the tap. I did it and it works. But distilled water is a lot better because there's less contaminants and less stuff that can like fuck the reaction up. So let's get right into it. Alright, so this is my little setup. Here I have like a big beaker full of distilled water. Here's an aluminum flask which will be used for the actual reaction. And here is my small beaker. It's slightly scratched on the bottom because of my stirring, like really bad stirring. But oh well. So I will start the reaction in a few seconds. One thing I forgot is a pipette. No, you don't need a pipette for this project. I use a pipette because I'm an idiot who broke his stir rod. And I will have to stir using a pipette. So let's get right into it. The angle is good enough. So first I will make permanganate solution. It has to be like really dilute, and obviously here water. Now I will maybe add more water. Like this is not enough for the sodium hydroxide. And the manganate too. So, whoa, this is too much. So, right now, prepare that you'll be watching me pour water in and out of the beaker. Alright, so now there's enough water for the reaction everywhere. So let's start. So potassium permanganate, this has to be like a really dilute solution. Because potassium permanganate is really colorful. It's like really colorful, so like this amount. You see this little of the permanganate. And now watch how colorful will it be. Like it was like 5 crystals. And the solution already is like really purple. Like pink purple, pinkish purple. Stir it until everything dissolves. There are a few chunks left. So right now maybe the sugar solution, like for this project amounts aren't that necessary. You just want an alkali sugar solution. First, the sugar. Like obviously I'm saying don't use a pipette for stirring. I'm using a pipette for stirring just because I broke my stir rod and I don't have money to buy a new one. So yes, I'm a broke chemist. Come support my Patreon if you're feeling generous. It will help me buy a real stir rod. Like with sugar, it's like the most of the sugar dissolves really well, but the last part is like it's a struggle to dissolve. Just have to stir it, and then like with this motion you have to break up the chunk of the sugar that forms in the middle. So like yeah, it's now dissolved. So I pipe that out, and now the hydroxide. And here comes the dangerous part, because sodium hydroxide is quite caustic. Like not too much. You don't want that to be like a lot of hydroxide, you don't want to waste it also. But yeah. Now we have to dissolve the hydroxide. The solution is quite exothermic, so the solution heats up quite a bit. It's not like terribly, but well, a caustic chemical is a lot more caustic when it's hot, so but like it quickly like dies down, it quickly cools down. So it's like not an extreme problem. And obviously like don't panic. If you spill some of yourself, just rush to the nearest water station, to like tap or something, to a shower, and wash yourself. If you got some in your eyes, just wash out from the eyes, and you'll be fine. So, we got our solutions. We've got our solutions ready. So now, let's do it. So now I'm gonna set up the camera a bit differently. I'm gonna set everything up a bit differently. Oh well, let's start the reaction, so I'm gonna add the sugar solution, and you see it changes color. It gets green. Quickly I'm gonna grab my flashlight to show you. It turns green. It's green, and now it will get yellow. It got blue for a moment at first, but like this blue is so dark that it's like impossible to see. Well, it is possible to see, but it's really hard to see still. So now it gets yellow, and it will get like nearly red in a while. Like as you can see, it gets like kind of orangey. So now I'm gonna explain quickly how it works. So potassium permanganate. You see this GHS symbol at the top? It means it's an oxidizer, and potassium permanganate is a really strong oxidizer. And sucrose is a reducing agent. Sugar is a reducer, and a reducer and oxidizer are basically the exact opposites. Reducers reduce the oxidation state, while oxidizers increase it. So here, because sucrose is a mild reducer, we need sodium hydroxide for them to react, as it needs to be done in an alkaline medium. So this causes them to react, and first it goes to this. I don't really know what is the blue oxidation state and what's the compound, but when it gets green, it becomes not potassium permanganate, but potassium manganate. So here we have like KMNO4, but then it is KMNO2, K2MNO4, which means the potassium permanganate is on a lower oxidation state. Like here, it's 7. It's a really high oxidation state. But then it gets like to 5. I think it's 5. Yes, it's 5. It's an oxidation state of 5. And now, when it's like brown, the brown color is from manganese dioxide, which forms, which is basically brown, and it's on an oxidation state of +4. In the meantime, sucrose gets oxidized, but really it doesn't like mean anything for the colors. So it's definitely less interesting, and like organic chemistry with saccharides, sugars, it's like higher level. So it was easier to explain on the manganese. Plus, it shows you with some really nice colors. So this is the reaction. It didn't turn red, sadly, but well, it's a really nice reaction. I hope you enjoyed watching this. And one really important thing. This is manganese. It contains a lot of manganese. Either in form of ions or compounds, and some manganese ions like permanganate ions, manganese 7 ions, like are quite neurotoxic. Well, not in the way that you will die by working with it, but like plants or fish may die if you like dispose of it improperly. So yes, deal with the waste properly. If you don't have an access, like a proper chemical tank to just pour everything in and forget about it, you may want to dump it into the drain. But remember, do it with an enormous extra water. Because as you can see, like the most bottom, it's bad for the environment. So I hope you enjoyed this really colorful reaction. If you really enjoyed this video, consider subscribing, liking the video, and maybe, if you're feeling generous, donate to me on my Patreon, PayPal, so I will be able to finally buy a proper stir rod. Thanks.